Hi children, welcome to another chemistry class, and today our discussion is the chapter Amines, organic chemistry chapter Amines from the 12th standard topic. Can we start? Ready? Yes. The first question. Number of structural isomers possible from the molecular formula C3H9N. You know C3H9N, it is propyl amine, 3 carbon atom. It go for propyl amine. CH3, CH2, CH2, NH2. Count the atoms, 3 carbon atom, 9 hydrogen atom, 1 nitrogen atom. This is propyl amine. And how many isomers are possible for this? That is the question. Right? Very simple question. All of you know the answer also. And it is 4 isomers are possible. Option 3 is the correct answer. 4 isomers are possible. Number 1, N-propyl amine, which I have written just now. Next one is isopropyl amine. So N-propyl amine means 1 amino propane, right? Or propan 1 amine. Then propan 2 amine, isopropyl amine. Then ethyl methyl amine, that is N-methyl ethanamine. N-methyl ethanamine, third one. And trimethyl amine, N-dimethyl methanamine. That is a molecule. So try writing the IUPAC name of the compound also. There are 4 isomers possible. 2 are primary amine. This is a primary amine. This is also a primary amine. While this is a secondary amine. While this is a tertiary amine. Among 1 and 2, they are position isomers. While this one with this, it will be functional group isomerism. This will be functional group isomerism. Primary amine, secondary amine, tertiary amine stands for what? Functional group isomerism. Right? Next question. The following reaction, aniline treated for benzoylation reaction. You know what is benzoylation reaction? You have heard about Schotten-Bowman reaction. Benzoylation of phenol, aniline, etc. called Schotten-Bowman reaction. You are getting the product. See, one of the hydrogen and chlorine will be released and you get it connected. Phenyl group with NHCO phenyl. And the name of the molecule is, what is IUPAC name? What is IUPAC name? N-phenyl benzamide. N-phenyl benzamide. And the reaction is Schotten-Bowman reaction. Schotten-Bowman reaction. The other reactions are known to you. And this is what fourth option, Perkins reaction. Our answer is second choice. What is Perkins reaction? Product obtained is alpha beta unsaturated aromatic acid. You are getting alpha beta unsaturated aromatic acid reacting an aromatic aldehyde with a acid anhydride. Either in the alkali medium or acid medium, you are getting alpha beta unsaturated carboxylic acid. This is the functional area. This is alpha carbon and this is beta carbon. Alpha beta unsaturated carboxylic acid obtained by reacting what? Benzaldehyde with the acid anhydrides. That is called a Perkins reaction. Not in the syllabus, but you need to learn that. Next one. So the answer for this question, no doubt, it is second choice, Schotten-Bowman reaction. Next one. Method by which aniline cannot be prepared. Method by which aniline cannot be prepared. Reduction of nitrobenzene with hydrogen palladium, you know, nitrobenzene reduced to aniline. Potassium salt of thalamide treated with the chlorobenzene followed by hydrolysis with aqueous NaOH solution. That is the answer. That is the answer. With this reaction, you cannot produce the aniline. Why? Because the reaction is Gabriel's thalamide synthesis. And all of you know Gabriel thalamide synthesis is a nucleophilic substitution reaction which is not favored for the production of aromatic amines. It is not meant for aromatic amine, it is meant for the aliphatic primary amines. Gabriel's phthalimide synthesis. Third one, hydrolysis of phenyl isocyanide with acidic solution. See, isocyanides upon hydrolysis, you get amines. While cyanides upon hydrolysis, you get carboxylic acid. Isocyanides upon hydrolysis, you get amines. Degradation of benzamide with bromine and alkaline, that is Hoffman's bromamide reaction. So all the reactions you are getting primary amine, whether aliphatic or aromatic, while the one you don't get is second choice, that is Gabriel's phthalimide synthesis. All of you remember the reaction. This is phthalimide treated with the KOH solution and you are getting potassium phthalimide. And that potassium phthalimide react with the RX. This is what the point mainly we are discussing now. Instead of RX, if you are getting chlorobenzene, C6H5Cl, instead of RX, aliphatic halide, if you are giving chlorobenzene, you can get aniline as a product, but you can't give. See, at this position, you can't use this because the reaction is nucleophilic substitution. This X is replaced by this nucleophile and you are getting N-alkyl phthalimide. That reaction is not possible if you are taking chlorobenzene. Why? Because chlorobenzene is extremely less reactive towards nucleophilic substitution reaction, all of you know. So that is a problem there. And coming back to the reaction, this you are getting N-alkyl phthalimide. Upon hydrolysis, you are getting primary amine. This part of the molecule will be converted to primary amine and the remaining will be converted to sodium phthalate. This is Gabriel phthalimide reaction used for the preparation of aliphatic primary amines, not aromatic. Hope you understood. Next question. Which one of the following nitro compounds does not react with the nitrous acid? With the nitrous acid, all nitro compounds can react primary, secondary, but not tertiary. Tertiary nitro compound cannot react with the nitrous acid because nitrous acid requires presence of alpha hydrogen. This is not having alpha hydrogen and this is the answer which will not react. Here you have alpha hydrogen, here you have alpha hydrogen, here you have alpha hydrogen. This is primary nitro, this is secondary nitro, while this is tertiary nitro, and tertiary nitro compounds cannot respond with the nitrous acid. This is what the reaction which is involved in Victor Meyer's test, testing for primary, secondary, tertiary alcohols. Same, the reaction coming in that sequence also, right? And this is what happening. Primary nitro compound with the 2 hydrogen atom, you will be getting the interaction with the nitrous acid. You will be getting this one. This is called nitrolic acid. Nitrolic acid. So primary nitro compound is reacting in that way. Okay. Secondary nitro compound. This is not primary. Secondary nitro compound. You will get pseudo-nitron. This is wrongly given. The product obtained is N double bond O. N double bond O. You are getting pseudo-nitron. This is nitrolic acid. This is nitrolic acid. And this is pseudo-nitral. Pseudo-nitral. That you are getting from secondary nitro compound. While tertiary nitro compound, there is no reaction. In the first case, nitrolic acid dissolved in alkali, you are getting a blood red colored solution. While in the second case, pseudo-nitral generally forms a blue colored solution. While the third one, there is no color, no reaction. Okay, next. A given nitrogen containing aromatic compound react with the SnHCl followed by HNO2 to give unstable compound B. B on treatment with the phenol forms a beautiful colored compound C. With the molecular formula given, structure of the compound A is, see, A reacting with tin and HCl. A reacting with tin and HCl. Usually it can be this or this, right? But this is not the point, and the investigation will tell you this is the answer. Because nitro group, tin with HCl converted to amino group. Amino group with the nitrous acid, you get unstable compound, that is disonium salt. And let us examine the reactions involved. What are the reactions involved? This is the compound A, nitro compound, nitrobenzene, reduction with the tin HCl, you are getting aniline. Aniline with the nitrous acid, you are getting benzene disonium chloride, which is unstable and can be stable at a low temperature. Now, that is treated with the phenol. What is the reaction? What is the reaction? That is coupling reaction. You are getting coupling reaction and you are getting azo product, para-hydroxy azobenzene, somewhat yellowish orange colored dye. Referred in the text, all reactions available in the NCERT, and you are learning that reactions. Next, and the answer is fourth choice. Next one, increasing order of basic strength. Increasing order of basic strength. See, basic strength for amines, particularly substituted aniline. Basic strength, all of you know, the presence of electron donating group increases the basic strength. Presence of electron withdrawing group decreases the basic strength. This is electron withdrawing group, and that is minimum. So 2 will be minimum. 2 will be minimum. This is electron donating group. 3 will be maximum. So the order is 3 maximum. Basic strength order 3 maximum, and then 1 and then 2. Answer is fourth choice. It is 2 minimum, then 1. There is no substituents available. So this is minimum, then this, and then this maximum. 2, 1, 3. Fourth choice is the correct answer. Next one. Identify A and predict the type of the reaction. Metabromoanisole treated with NaNH2. This is a reaction involving benzene mechanism. This is a reaction involving benzene mechanism, which not in the syllabus, but we need to learn that all the possibilities. Let me tell you all the possibilities concerned. What are the possibilities concerned? Let me tell you the various possibilities concerned. Let us investigate in detail the various possibilities concerned. This part I will explain later. Let me explain this first. You see, elimination, addition, benzene reaction of bromoanisole. Here, first case we have taken orthobromoanisole. Orthobromoanisole treated with the NaNH2 liquid ammonia. What you are going to get is, what you are going to find is, this hydrogen is attacked. This hydrogen is getting attacked. This hydrogen is getting attacked by NH2. So NH2 minus with the hydrogen, ammonia gone. So you are getting a minus character over the meta position. And now bromine is eliminated. Now the bromine is eliminated while this electron density will be migrating here, and this is what called benzene. Benzene in the word. That's benzene. Benzene. Now that benzene attacked with again NaNH2 ammonia. NaNH2 ammonia. What is going to happen? What is going to happen? You see, minus character shifted to this position. You are getting a minus there, coming close to the COCS3 group because of the electron withdrawing nature of the electron withdrawing means minus I character of oxygen. Due to minus I character of oxygen, we can find minus is coming there. The electron density is coming to that position, and you are getting a electron rich center there. Electron rich center there, and quite naturally this will be a positive center, and in the positive center ammonia will attack, amide will attack, and you are getting a group like this, and now H plus is reverting to this position to get the final product meta-amino-anisole. Right? Meta-amino product is obtained. Now imagine bromine is in the meta position. Bromine is in the meta position. The result is the same. How is the result the same? Once again, this hydrogen is withdrawn and you are getting a minus here. Right? And now this bromine is gone and this bromine is gone and you will get a benzene. The same thing will be formed there. Right? And the result is quite the same. The product obtained is quite the same. See, after that, whatever happening is the same way. So once again, amino group is coming in the meta position, right? Suppose bromine is in the para position. Suppose it is in the para position, this hydrogen is withdrawn, you are getting a minus here, right? And now it can form a benzene over here. It's forming a benzene over that position. Now the result is you can get NH2 group at a para position and of course at a meta position. You can get a result in the para position, amino group coming at para position and also at a meta position. So see, suppose it is orthobromoanisole, you are getting meta amino product. If it is meta bromoanisole, you are getting meta amino product. If it is para bromoanisole, you may get a meta as well as NH2. So go for all these possibilities. But the most common encountered product, no doubt, meta amino product. And what is the controversy in this point? Nothing but OCS3 group is orthopara directing. OCS3 group is orthopara directive. So the new group expected to be at a orthopara position, but it is coming at a meta position. Right? So wherever bromine is eliminated from the meta position, if it is the same position, amino group is coming. Right? That is what happening. And the answer here is which one? Second choice. Second choice. It is basically a substitution reaction. Addition followed by elimination. Addition followed by elimination. Means a substitution reaction is happening there. And there is a terminology in the third choice, sign substitution. What is this? Sign or sine substitution. Sign substitution, you need to know certain terminology concerned to that also. These are not in the syllabus, but you are supposed to know all those points. Ipso substitution, sign substitution, tele substitution, etc. Ipso substitution. What is ipso substitution? Two substituents sharing the same ring position in an intermediate compound in an electrophilic aromatic substitution. This is what called the ipso substitution. Somebody sharing the same position here as an intermediate. That is ipso position. Ipso. What is meso? Meso means refer to the substituents occupying benzylic position. This is benzylic position and a substitution happening there. We call it as meso position. And what is peri? Peri position. Peri substitution occurs. Peri substitution occurs in naphthalene. Naphthalene. You see, this is peri substitution. A naphthalene molecule, and that is peri substitution. 1-8 positions coming is called a peri substitution. And now one more. Sign substitution. What is sign substitution and what is tele substitution? So ipso means same position shared by two groups as an intermediate. Meso means benzylic position. Peri means something like a naphthalene molecule. Sign substitution means the entering group take position adjacent to that occupied by the leaving group. Entering group comes in the adjacent position that to the leaving group. That is sign substitution. What is tele substitution? Tele substitution means new position is more than one atom away from the ring. Okay, tele substitution means the new position is more than one atom away on the ring compared to the leaving group. That is tele substitution. So just have a picture regarding these various kind of substitutions. May there can be an advanced level question from the area. Amines is a chapter, simple chapter, but many questions are coming, sometimes even 3 questions also we can expect from the chapter. Okay. That's why some additional points also encountered. So the answer for that question will be second choice. Second choice. This bromine will go and there will be NH2 group. Next. But remember, it is happening via benzene mechanism. Okay. Next. Which is appropriate for converting acetamide to methanamide. Acetamide to methanamide. Hoffman degradation reaction. In a degradation reaction, 1 carbon less, the product obtained will be having 1 carbon less. You see, acetamide means ethanamide. Ethanamide converted to methanamide. Have a look at the reaction. Have a look at the reaction. This is acetamide, ethanamide. This group will go ultimately and you are getting methyl amine. And how is the reaction taking place? It is treated with the bromine NaOH, HBr out, and you are getting bromamide. That is bromamide. And now that bromamide once again react, you get a nitrate. This is the important intermediate. Nitrate. And in nitrate, there is a rearrangement. This methyl group is shifted to nitrogen and you are getting methyl isocyanate, which upon hydrolysis, you are getting CH3NH2. CH3NH2 releasing sodium carbonate. This is Hoffman's degradation reaction. Hoffman's bromamide reaction, where the net result is 1 carbon will reduce. Acetamide, ethanamide will give you methanamine. Propanamide will give you ethanamine. Butanamide will give you propanamine. Like that. Okay? Answer is second choice. The other reactions are known to you. Next. Nitration of aniline in strong acidic medium also gives meta-nitroaniline because option 4, in acidic medium, aniline is present as anilinium ion. The NH2 group in aniline is subject to protonation in acid medium. Once it is protonated, NH2 group becomes NH3 plus group and now act as a meta-directing group. And see what is happening? Aniline upon protonation becomes anilinium ion and this act as meta-directing. Is it all meta product? No. Is it all meta product? No. It's referred in the textbook, all of you know. 51% you get a para product and 47% a significant quantity of meta product is obtained, while ortho product is only 2%. Basically, this group is ortho-para directive. Basically, NH2 group is ortho-para directive. But in strong acid medium, you are getting a significant amount of meta product, 47%. Why? That is the question. The answer is fourth choice. Due to the formation of anilinium ion. This is the answer. Next. Which will give carbylamine test? Carbylamine test is given by whom? Carbylamine test is given by whom? Primary amines. Primary amines will give you carbylamine test. This is secondary amine, tertiary amine, secondary amine, and this is primary amine that will give you carbylamine test. When treated with the chloroform and alkali, you are getting a foul smelling product. And what is the reaction? What is the reaction? This is what the reaction I think all of you are aware of. This is what the reaction happening there. If you don't know the mechanism, try to understand. You see chloroform interacting with the base and you are getting this one and that is converted to dichlorocarbene, a species well known to you. So chloroform with the alkali, you will get dichlorocarbene, a reactive well known intermediate. And now dichlorocarbene attacked by primary amine. This is attacked by nitrogen and you are getting such a molecule. Right? And now what happens? This hydrogen is gone. This hydrogen is gone and one of the chlorine gone and you are getting this product. Again, hydrogen goes and chlorine goes. You are getting the final result. you are getting the final result RNC. RNC. This is what the reaction happening, and this is happening with the primary amines only. This is a test for primary amine. The foul smelling product obtained is a test for primary amine when treated with the chloroform and alkali, and the foul smelling product obtained is nothing but isocyanide, that is isonitrile, which is called a carbylamine. Okay, next answer is fourth choice. Following compounds can be classified as N-N-dimethylpropanamine. N-N-dimethylpropanamine. This is N-N-dimethylpropanamine, which is a tertiary amine. Answer is option D. N-methyl-aniline. N-methyl-aniline. This is N-methyl-aniline, which is a secondary amine, and aniline is a primary amine. So, tertiary, secondary, primary, respectively. Okay. You see, this is tertiary, this is secondary, and this is primary. Next. Cyanides and isocyanides can be reduced respectively to. Cyanides can be reduced to primary amine. Isocyanides can be reduced to secondary amine. Cyanides reduced to primary amine. Cyanides reduced to primary amine. This carbon will turn CH2. This nitrogen will turn NH2. You get primary amine. This nitrogen will turn NH, and this carbon will turn CH3. You get a secondary amine. Answer is option A. Primary and secondary amine respectively. Next, basicity order. Basicity order. See, basicity order for ethyl amines. Basicity order for ethyl amines. See, methylamine, ethylamine, different amines having different order. The order of methylamine and ethylamine are not the same. It depends on the primary, secondary, tertiary nature. It depends on the groups surrounding. It depends on the electronic effect. Depends on the steric factors. Depends on the solvation effect. So various factors controlling the stability of conjugated acid, and depending on the stability, depending upon which the basic strength is coming. Right? So methylamine, the order, and ethylamine, the order is different. Right? For methylamine, the order is, you have learned for methylamines. For methylamines, the order comes as secondary greater than, primary greater than, tertiary greater than ammonia. While for ethylamines, what is the order? For ethylamines, what is the order? The order is secondary amine greater than, tertiary amine greater than, primary amine greater than ammonia. This is the order. And you can memorize that very easily. You can memorize that very easily. You see, methyl means a small group. The order is 213, small figure. Ethyl is a bigger group. The order is 231, a bigger value. Just memorize like that. 213, 231. 213, a small figure for the small methyl group. Easy to memorize. And what makes the difference between these two groups? Methyl group and ethyl group. Methyl group and ethyl group is little more bulkier. So there is a significant steric factor coming in ethyl group, ethyl amines. Right? And the order you can easily memorize. So what is the order here? For ethyl amine, what is the order here? Secondary maximum. Secondary maximum. We have only one choice. Secondary, tertiary, primary, ammonia. First choice is the correct answer. Secondary, tertiary, primary, ammonia. If it is methyl, secondary, primary, tertiary, ammonia. Okay? Yes. Increasing order of boiling point. Boiling point, maximum alcohol, minimum alkane, 1 minimum, 3 maximum, 1 minimum, 3 maximum, 1, 2, 3. This is minimum, then amine, and then alcohol. In alcohol, the extensive hydrogen bonding occurs. In alcohol, there is extensive hydrogen bonding, and the molecular attraction increases, and the boiling point is maximum. That's it. While in alkanes, there is no polarity. Okay, next. Once again, the decreasing order of boiling point, but now it is different species. Now it is different species. I mean, not alcohol, amines only. Between amines, there is a comparison. How comes the boiling point? How comes the boiling point of amines, primary, secondary, tertiary? Very simple to understand. Primary will be maximum. Primary will be maximum and tertiary will be minimum. Once again, due to hydrogen bonding. Hydrogen bonding is maximum in primary amine, minimum in tertiary amine. Hydrogen bonding maximum in primary amine, minimum in tertiary amine. So it is 1 maximum, 3 minimum. 1, 2, 3. First choice. Why? In primary amine, 2 hydrogen. Secondary amine, 1 hydrogen. Tertiary amine, no hydrogen. So the hydrogen bonding character will decide the boiling point. Molecular attraction and hence the boiling point. Answer is first choice. Next one. An amine absorbs 3 mole iodomethane to form quaternary ammonium salt. The amine is all will absorb 3 mole iodomethane. Suppose you are taking a primary amine. Suppose you are taking all are primary amine. Suppose you are taking any primary amine when treated with iodomethane. What are you going to get? What you are going to get? You will get RNHCH3. First one. RNHCH3. First one. Now you are repeating the reaction. Now you are repeating the reaction CH3I. You will get RNCH3CH3. Now it can react once again. It can react once again using the lone pair. That is CH3I. Once again it react. You get RNCH3CH3CH3 plus I minus. This is quaternary ammonium salt. So primary will be converted to secondary, 1 mole. Secondary converted to tertiary, 1 mole. Tertiary converted to quaternary, 1 mole. 3 mole will be interacting with the primary amine. All are primary amine. Option A, B, C, D, all are, A, B, C, all are primary amine. Next question. Identify Z in the reaction. Identify Z in the reaction. See, X is benzene diazonium chloride. X is benzene diazonium chloride. And then Sandmeyer's reaction, cyanobenzene. Upon hydrolysis, you get benzoic acid. You get benzoic acid, option C. This is the answer, benzoic acid. You see the reactions involved. What are the reactions involved? This NH2 group converted to diazonium salt, treating with the NaNO2HCl, diazotization. And now this is Sandmeyer's reaction. This is Sandmeyer's reaction. And you are getting cyanobenzene. And cyanobenzene, upon hydrolysis, this carbon will be converted to COOH. And you get benzoic acid. That is the sequence. Right? Next one. Aniline diazotized in cold when treated with dimethyl aniline gives a colored product and the structure is. So dimethyl aniline with the diazonium salt. Dimethyl aniline with the diazonium salt. Option C, the product will be this one. Product will be this one because this is the part of diazonium salt and this is N-dimethyl aniline. N-dimethyl aniline. And see the reaction concerned. Look at the reaction concern. Aniline treated for diazotization. You are getting benzene disonium chloride, and that treated with the NN dimethyl aniline. It is attracting here. Attacking here. Para position substitution, electrophilic substitution reaction, and you are getting azo product. Azo product, NN dimethyl azobenzene. NN dimethyl azobenzene. That is the product. Coupling reaction. Coupling reaction. Next one. Which will give effervescence with NaHCO3. See, effervescence with NaHCO3 happens with the acid solution. Which is acid solution? First one is base, or rather it is amphoteric. First one is amide. Amide is amphoteric. Second one is base. Third one is base. Fourth one, this is the answer. This is the answer. Here it is CS3, NS3 plus and Cl minus. It is a salt of weak base and strong acid. The solution is acidic. See the fourth choice. It's a salt of weak base and strong acid, and it is a acidic solution, and that will give you effervescence. Right? And the answer is fourth choice. Next one. Hofmann's elimination reaction of a certain amine gives as the final product. The amine is option A. Option A, C6H5, CH2, CH2, NH2. Option A. And what is the reaction happening? See, what is the reaction happening? This is the molecule A treated with the excess of CH3I. You are getting a quaternary ammonium salt. You will get a quaternary ammonium salt like this. That is exhaustive alkylation. AR, that is benzene, CH2, CH2, N, CH3, CH3, CH3 plus and I minus. This is a quaternary ammonium salt. A quaternary ammonium salt upon heating, what will happen? What will happen? It is going to break here, and this part of the molecule will be converted to tertiary amine. You see, tertiary amine. And what is happening to the remaining part? The remaining part will be converted to an alkene, and that is least substituted alkene. Normally you are getting least substituted alkene, that is Hofmann's elimination. While in Seychef elimination, most substituted alkene is the major product. Here this is Hofmann elimination. You are getting least substituted alkene as the major product, and you see here there is only one product, no matter of talking most or least. A double bond will appear here, and you get the concerned product we are talking in the question. Is it clear? Hofmann's elimination reaction. Hofmann's elimination reaction, also not in the syllabus, a point which you need to learn as an additional point, because at times you can expect a question. Okay, next. IUPAC name of the given molecule is. IUPAC name of the given molecule is. What is IUPAC name? How to start the numbering? It is 1, 2, 3. Propan, proper 2 in 1 amine. Proper 2 in 1 amine. Option C. Option C. Proper 2 in 1 amine. Next. A primary amine on exhaustive methylation followed by treatment with moist silver oxide and then heating to 400 liberated 2-methyl propane. The starting material is. See, suppose the starting material is N-butyl amine. Suppose the starting material is N-butyl amine. You see, I will draw the skeleton only. N-butyl amine. This is N-butyl amine. Okay. Now this is treated for exhaustive methylation. It is treated with the CS3I. Just imagine. You will get this. This again treated with the CH3I. You will get the next product. You see, primary amine turn secondary amine turn tertiary amine. Now again it reacts. Again it repeats. You get a quaternary ammonium salt. And this quaternary ammonium salt, upon heating, what will happen? That is what I said earlier. In Hofmann's elimination, it is going to break here. This is removed as trimethylamine, and this part of the molecule will be converted to alkene, and you will get least substituted alkene, means the double bond come in the first position. You get 1-butane. You get 1-butane as the major product. This is Hofmann's elimination product if you take option A. But that is not what asked. What asked is for 2-methylpropene. And the answer will be option D, isobutylamine. It will be isobutylamine. Let's see the reaction. Isobutylamine. Oh, reaction is not given. I will write. Isobutylamine. This is isobutylamine. Suppose we are doing exhaustive alkylation. 3-step exhaustive alkylation. The final product will be, I think you are okay with, because it is a mere repetition, so I am not writing the individual steps. This is the quaternary ammonium salt you are going to get. And now what happens? See, this part of the molecule will be converted to alkene, and you can expect a double bond here, and the final product will be C double bond C like this. That is 2-methylpropane. You are getting 2-methylpropane as the product. So I have explained option A and option D, the correct answer. You please examine what will be the product of Hofmann's elimination product, option B and option C. You try that. I am leaving to you. Option B if you take, what will be the product? Option C if you take, what will be the product? You try. Do it as an exercise. Here the answer is option 4. How it is for this part? You look at this part, you will get your answer. Okay, next one. The following sequence end product is ethanamine, nitrous acid, you get ethanol. Ethanol associated to you get chloroethane. Chloroethane with the KCN, you get propane nitrile. Propane nitrile. Option A is the correct answer. Option A is the correct answer. Ethylamine with the nitrous acid. Ethylamine with the nitrous acid, it will be converted to ethanol. All of you have learned. Aliphatic primary amine converted to alcohol when treated with the nitrous acid. Because aliphatic diazonium salts are unstable at any temperature, it will be immediately hydrolyzed to give alcohols. So aliphatic primary amine converted to alcohol. Alcohol with the SOCl2, thionyl chloride, you get chloroethane. Chloroethane with the KCN, chlorine goes and you get CN, and this is propane nitrile. This is to be called as 1, 2, 3. Propane nitrile. Propane nitrile. Option A. Next one. Correct order of basic strength. Now see, this is for methylamine. This is for methylamine, and hope you remember what I told. It is tertiary. It is secondary greater than, primary greater than, tertiary greater than, ammonia greater than aniline. Because you know, aniline is less basic than ammonia. Aliphatic amines are more basic than ammonia, while aromatic amines are less basic than ammonia. So what is the order? Secondary amine maximum. Secondary amine maximum. So that is the order. Secondary, primary, tertiary, ammonia, aniline. Aniline less basic than ammonia due to resonance. Aniline less basic than ammonia due to resonance. While aliphatic amines are more basic than ammonia. Among aliphatic amine, methylamine, what is the order? Secondary, maximum. Then primary, then tertiary. Next question. Careful nitration of aniline in strongly acid medium gives 47. This is already discussed question. Which one is the answer? Option C. Already commented in detail. Already commented in detail. NH2 group get protonated to get anilinium ion. Next. Next, that is a different reaction. Sometimes you might have heard about Zenin's reduction. That is selective reduction. If there are two NO2 group, one group is reduced to ammonia. Amine. Out of the two NO2 group, selective reduction of one group, that is called Zenin's reduction. Zenin's reduction is conducted by compounds like ammonium sulfide. Compounds like ammonium sulfide will give you a selective reduction. Out of the two, one is reduced. That is called Zenin's reduction. Zenin's reduction. Selective reduction of dinitro compound done by using sulfides and polysulfides called Zenin's reduction. Right? Not in the syllabus, but an additional point which you can make a note on too. Next one. End product of following reaction. End product of following reaction. End product of following reaction. You see, this will treated with hydroxylamine. Ketone with hydroxylamine, you get oxime. Oxime reduction, you get amine. Amine nitrous acid, you get alcohol. Alcohol SOCl2, you get chloro compound. And the final result could be this one. Let us examine the reaction. Let us examine the reaction. Yes, you see that. Ketone with hydroxylamine, you are getting oxime. Oxime with lithium aluminum hydride, you get amine. This is reduced to amine. Amine, this is aliphatic amine. This is aliphatic amine, don't confuse. It's not aromatic. Aliphatic amine with the nitrous acid, you get alcohol. You get alcohol. And that alcohol with SOCl2, you will get chloro compound. Chlorocyclohexane with alcoholic KOH, there will be elimination reaction. Chlorine goes and the hydrogen from here goes. You get a double bond here and the product is option E. Next. Identify the end product. Once again, CONH2 dehydrated. CONH2 dehydrated, you will get a cyanide. A is cyanide. Cyanide, lithium aluminum hydride. You get amine, primary amine. Nitrous acid, you get ethanol. Answer is option D. Answer is option D, and the reactions are CS3CONH2. See, water is out. This is a dehydrating agent. You are getting cyanide. Cyanide upon reduction, you are getting C converted to CH2, N converted to NH2. You get primary amine. That with the nitrous acid, you are getting ethanol. Being aliphatic amine, nitrous acid gives you ethanol. And the result is fourth choice. Next one. The indicator obtained by coupling diazonium salt of sulfanilic acid with the NN-dimethyl aniline. Methyl orange. Methyl orange. Coupling reaction. You see what is the product of, what is the reaction happening? This is what the reaction happening. Sulfanilic acid with the sodium carbonate, you are getting salt of sulfanilic acid. Upon diazotization, this is converted to diazonium salt. And that treated with the PHNMe2. That means NN-dimethyl aniline. This is NN-dimethyl aniline. There is a coupling reaction happening and you are getting methyl orange. That is methyl orange. Parallelly, look at other compounds also. This is the structure of phenolphthalein. You might have seen. This is the structure of phenolphthalein. That is not a azodide. That is the one and only azo dye. And this is malachite green. This is malachite green, another dye. And this is methylene blue, methyl blue, another dye. These are all different pigments, dyes used in the analysis reactions. Okay. And that is coupling reaction. That is coupling reaction using NN-dimethyl aniline with the sulfonuric acid salt. Next, butylamine, methyl propylamine are. Methylamine, butyl propylamine are. See, this is butylamine. This is butylamine. Methyl propylamine. This is methyl propylamine. They are functional group isomers. This is not NH3. This is NH2, isn't it? So this is a primary amine and this is a secondary amine. So what is the isomerism between primary and secondary amine? They are functional group isomers. Primary amine, secondary amine, tertiary amines are functional group isomers. Okay. And that was the last question from the chapter. There we conclude the discussion of the chapter amines. A simple chapter compared to the other big organic chapters, but the number of questions coming from the chapter is a bit high. Many times we have seen it is 3 questions may come from that chapter. So study well, do it well. We will meet with another chapter in another class. Bye, see you, take care.